Welcome to React Basics. In this course, you'll be introduced to the basics of working with React. During this module, you'll learn how to develop a working familiarity with the basic structure and use of the React.js library, explore the concept and practical use of state and state management, and discover how to set up navigation and make use of assets in your React apps. You'll begin by learning how to work with React to build modern user interfaces, or UIs, on website front ends. This involves the concept of standalone parts of the user interface, or UI. These standalone bits of UI are commonly referred to as components. You'll explore components in more detail later in this module. For now, it's enough for you to know that every website's UI is built on a foundation of components and composability. Simple components combine into more complex ones, which eventually merge to form a website. So, a website can essentially be viewed as a highly complex component. Components in website UIs are not limited to React, but a part of the reason why React is so popular is because it streamlines the process of building and composing components. React does this efficiently and without a significant impact on your browser's resources. Another major topic that will be discussed in this course is working with state in React apps. You'll learn a lot more about state as you go through the course, but for now, here's a simple definition of state. State is simply all the values of all the variables your app is working with at any given point in time. As you progress through this course, you'll also learn about how to style your React apps, which includes the reuse of common styles, setting up your apps to respond to events such as clicks and user-submitted data, creating navigation routes and using assets, and you'll finish off the course with a portfolio project where you'll apply your new knowledge. I hope you're as excited as I am to begin this course on React Basics. Let's get started.
My team uses React, and we use a lot of new and experimental features that the React team is building. Facebook.com is like a demonstration of all the new and cool features that React engineers are working on. So when we rewrote the website, we were actually using a lot of unreleased features and kind of experimenting with a lot of new things that the React team was building, which was really cool to kind of use it first. My name is Katie, and I'm a software engineer on the React apps team at Meta, and we work on building a variety of new features for Facebook.com. There are plenty of React-based apps that you've probably used before. Facebook and Instagram are two examples, but Netflix, Airbnb, New York Times, and a variety of other companies also use React for their websites as well, so you've likely encountered it before. These websites that tend to have really interactive UIs are more likely to be using something like React. So Facebook.com had become really not performant and not modern looking after the 10 or so years that we had been using it. We had squeezed all of the performance wins that we could out of Facebook.com. So really the only option at that point was to rewrite it on a different stack that was going to be a lot faster and a lot easier to build on. Basically, there was a need for having a really fast and responsive UI, and React fills all of those needs. So this was kind of a shift in thinking differently about how we build on web. We actually rewrote our website a couple years ago to be completely React. And so every engineer who's writing for Facebook.com at Meta is pretty much using React. I was there for the middle of it to finally launching it. So it was cool that a little bit of it was already written and we were getting prepared to show it to real users. I think 40 engineers on our team were all working on building out this MVP of the redesigned Facebook.com. And we would work with a variety of product teams to get them to also rewrite their product on our new stack as well. It was a really big effort, and it was also a really big risk. Not all the teams that we talked to thought that we could ship this new version of Facebook.com. So we really had to prove that it was faster. It obviously looked more modern, but we had to prove that it would really help these product teams deliver the best version of their product that they could on web. So React is open source, meaning that anyone can contribute to it. And those engineers are working full-time on React. But we also have developers who aren't at Meta who are also contributing to React. And that means that there's a really strong community around React. And a lot of people are really excited to build on it and make improvements to it. So if you ever have any questions or you have an idea about a certain feature or optimization or improvement, there's really like a great opportunity to actually contribute to the React library itself. So there's a React team at Meta, and this team is comprised of engineers who are working on React full-time, but there's also a group of developers outside of Meta who are contributing to React as well. I think the open source part of it is really cool just because there's such a community around React. It's constantly being updated and maintained, and there's always going to be someone available to like answer questions or to update documentation. It's very current. If you're using React for the first time, definitely take a look at our documentation. There are a lot of conversations being had about React online, and we actually have a React conference every year where we talk about new features with React, and you can just connect with a lot of React developers. So there are plenty of opportunities to get involved in the React community, and I think it makes building with React even more rewarding if you kind of connect with the community as well. React is used everywhere in the tech world, and you'll have the chance to use it throughout your career, so it's a very valuable skill set to have. Yeah. My name is Katie, and I'm a software engineer on the React apps team at Meta, and we work on building new features using React for Facebook.com. My first encounter with React was actually in a senior design project back at college. We were looking for a great client-side library to use for an app that we were building, and React seemed like the easiest to use and the fastest to build on. I had already gotten my job at Meta, but I didn't know what I was going to be working on at Meta, so it was cool to kind of get this experience with React. Realized I really enjoy working with it, and then get to do it in my day-to-day work. So I feel like in school you tend to do a lot of object-oriented programming, which uses inheritance. React doesn't use any of that. It uses something called composition. So that was a little bit difficult to think about, but there's so much documentation around React and such a strong community that it's easy to pick up, and you have support coming from so many different places. You can just go onto YouTube and watch a video, read through the documentation, or look at other open source projects that use React. So there's so many resources to pull from. I think developers outside of Meta choose to use React for the same reasons that we do at Meta. It's super easy to learn and pick up. You're able to create really custom UIs with React. We're building so many different features on Facebook.com every day that require a lot of custom components and UIs, so it's nice to have the flexibility that React provides. I would say React is the best choice for an app if your UI is really custom and you're looking for a lot of flexibility with what other libraries you can integrate for your app or website. React is just a front-end library. You're going to need to interact with other third-party libraries too. And if you want the flexibility of integrating with Redux or other third-party libraries, React is the perfect choice for you. React is also great if you have complex UIs where you want to reuse code across many different pages. So I think it's a great choice if you're building a complex website with a ton of features across a ton of different pages. I think React solves the problem of code reusability really well. Here at Meta, we have a core set of UI components that we're actually able to reuse across the site. And this means that we're able to build a lot of functionality into these core UI components, like accessibility. I think we're able to have a high quality bar across the site just because we're reusing components everywhere, and we're able to kind of share code even across Facebook and Instagram and Messenger. So I think that's a really unique part of React. It's really interesting because if I find a bug in a core UI component and I fix it, I'm not only fixing it for my one use case, I'm fixing it for use cases across the site. So I think it's a really smart way to use engineering effort. You're fixing a bug once and you're solving one problem everywhere. So I would say the biggest competitor of React is Angular. Angular is a bit different from React in that it's a full-fledged solution for an app or website. You don't really need to integrate with third-party libraries when using Angular, whereas with React, it's just a client-side library. So you do need to figure out how you're going to do routing and server-client communication. I would say React provides more flexibility with creating these complex custom UIs, whereas Angular makes it easier to create a single-page web application. with like an out-of-the-box solution. Learn by doing. Try to make an example app. Don't go and try to create the most complex app you've ever heard of. I would say start simple. Make sure you're using best practices. Continuously reference documentation to see if you're using hooks the way you're supposed to, and that sort of thing. And it should come pretty easily. I think one of the great benefits of React is how easy it is to pick up and learn. There are a lot of different pieces of React and a lot of different concepts to learn, but it's really well worth it in the end because you're going to encounter React in your day-to-day work, hopefully for the rest of your career. And there's a huge community behind you ready to help and answer questions about React too.
Recall the concept of the single page application, or SPA for short? This is a one-page website where some of the page's content changes based on user interaction. SPAs differ from traditional websites, where each web page needs to be loaded as the user navigates around the site. This frequent reload can be considered inefficient, as some of the same content such as logos, navigation and footers need to be loaded again. And one of the most popular ways to build an SPA is with the React library from Meta. React is used to run many of the world's most popular websites. Often on these sites, you'll type a search term into the site's input box. The site then returns the relevant content or results. But you might notice that even though the content has updated, the site's URL doesn't change. As SPAs only load the content as required, they can be ideal for businesses and enterprises who need a web app that offers rich user interfaces, speed, scalability, and flexibility. As an aspiring developer, you may feel like there are a lot of new concepts and processes to understand when working with React, but you can be sure that you will have an opportunity to get familiar with and use them. In this video, you will learn about the basics of React by exploring the concepts of the component-based architecture, components, and the virtual DOM. Let's begin with components, one of the core building blocks of React. When Meta released the React library, it included the concept of something called component-based architecture. This is essentially a design philosophy for building software based on reusable components of code. Each component consists of well-defined functionality that can be inserted into an application without requiring modification of other components. Because components are reusable, they can be used multiple times and easily inserted anywhere where needed. This results in components that can exist within the same space yet interact independently from each other. One of the advantages of developing using components is that many developers can work on the same project without interfering with the code of other developers' components. As you may recall, modern front-end web development revolves around the concept of creating standalone parts of the user interface, or UI for short. Well, in React, these standalone parts are created using components, which form the foundation of all UI design. It's important to know that all UI is composed of simple components that can be combined into more complex components. In fact, you can think of an entire website as just a collection of components. For example, consider the product checkout page of an e-commerce web application. The page consists of 3 sections: a header, a payment section, and a sidebar. The header section contains the company logo with a navigation menu and a button to view the shopping cart. The payment section area contains a form where the user inputs their payment information. Finally, there's a sidebar with the order summary information. As the components are self-contained, they have their own HTML, CSS, and JavaScript logic for functionality. For example, the payment section component has a JavaScript function that submits a payment when a button is clicked. It's important to know that the use of components in website UI design is not limited to just React. Many websites' front end or UI are built on the foundations of components and composability. But React is a powerful tool for streamlining the process of building components and composing them. It performs these actions efficiently as components are rendered to the DOM without significantly impacting the browser's resources. This is called component rendering, and you'll learn more about this and its associated render method later. You may recall that the DOM is a logical tree-like structure representing the HTML document, and it uses nodes to describe the various parts of the document. Before React, you could still build component-style layouts. However, it involved much more complicated DOM manipulation and code, making the layouts more complex and harder to work with. This resulted in something known as spaghetti code, a term developers use in web development to describe code that is complex, convoluted, and difficult to understand, like spaghetti. React prevents this spaghetti code by avoiding any manipulation of the DOM. Instead, React provides something known as the virtual DOM. You may recall that this is an in-memory representation or clone of the real DOM, which minimizes updates to the DOM itself. React uses the virtual DOM to update the browser DOM only when needed. This ensures that the update is as minimal as possible, increasing the application's speed and performance. In this video, you learned about the basics of React by exploring the concepts of the component-based architecture, components, and the virtual DOM. Recall how you learned about functions in JavaScript? They are reusable blocks of code that can take an input, perform some procedure or calculation, and then return an output. Well, a React component acts much like a traditional JavaScript function. In this video, you'll continue your exploration of the structure of the React architecture by learning about functional components, component types, JSX, and transpiling. React provides two types of components: functional components and class components. They behave very similar in React to traditional functions and classes in JavaScript. Don't worry about class components for now, you'll learn more about them later. Instead, let's just focus on functional components which act like a JavaScript function. In the default React application, only one component is rendered, and it's the app component located inside the index.js file that's located inside the source folder. It's important to know that every React app must contain at least one component, and it's called the root component. This component is loaded using the import statement. You'll learn more about the import statement in React later. For now, just know that it's used to import code needed for React to work, such as the import React and import React DOM statements. The syntax to render a component is very similar to a self-closing tag in HTML. You just place the component name inside the left and right angle brackets, and don't forget the /. The root component can contain other components that developers create to represent the various UI parts of the application, like in the e-commerce example that you learned about earlier. And recall that this component is ultimately converted to a DOM fragment and placed into the existing DOM as a child of the HTML div element with an ID of root. This div element is then rendered to the browser. If you analyze the app component, you'll notice that it looks very similar to a JavaScript function with some HTML code inside. You may also notice an export default statement. You'll learn more about this soon. For now, just know that you need it to make your components available. Okay, so now that you're familiar with the concept of functional components, let's explore how web developers create them in React. React is scripted using a special kind of syntax called JavaScript XML, or JSX. For many React developers, this is known as a syntax extension to JavaScript. So, what is JSX syntax like? Let's find out by going back to our React default app component. Recall that in the return statement of the app function, it seemed that some HTML content is returned. Well, this content is not exactly HTML, it's JSX. JSX syntax looks very similar to HTML, and one of its advantages is that it allows you to write JavaScript code inside what looks like HTML elements. In fact, you can think of JSX as a combination of custom HTML and JavaScript. This allows you to make your website dynamic. You'll learn more about the differences between HTML and JSX later. For now, just know that you can place this syntax inside the return statement of a functional component. It's also important to know that a React component won't render until it's used as a JSX element, just like a JavaScript function declaration won't run until it's called or invoked. Okay, so now you know what JSX is. Let's explore the steps involved to create a React component, which will contain some JSX code inside a heading 1 HTML element to display some text on a web page. First, you create the component, which is basically just a JavaScript file. Since its purpose is to return some heading text, you name the file heading.js. Notice that the first letter of the component name is capitalized. This is because there's a difference in how React treats capitalized and non-capitalized component names. So it's important to remember that all component names in React must be capitalized. Why is this? Well, because React treats lowercase components as regular HTML elements. Capitalizing a component name helps React to distinguish JSX elements from HTML elements. Now let's continue with our component. Next, inside the app.js file, create a function named heading. The function name must also be declared using a capital letter for the first letter of the function. Then, inside the function body, you create a variable named title and assign it the string value of "this is some heading text." Now you're ready to create the return statement of the function. Inside the parentheses of the return, insert a heading1 tag and inside it, place the variable named title. To make React evaluate the title variable, you need to place it inside curly brackets. If you didn't use curly brackets, you'd get the word title instead of "this is some heading text." At this point, it's worth remembering that while you are creating HTML-like syntax, you are actually coding inside a JavaScript file. And because of this, you can output a variable inside your JSX code, something you cannot do when writing static HTML. The overall syntax instructs React to render the heading HTML element with whatever text value that is stored within the variable named title. This rendering happens behind the scenes because of something called transpiling. You can think of transpiling as a process of converting JSX to HTML, and you'll learn more about this later. In this video, you learned about functional components and how to create them in React. You also learned about JSX, which acts like a combination of HTML, CSS, and JavaScript that you can use to generate dynamic content inside your functional components. Finally, you explored the concepts of rendering and transpiling. If you would like to learn about these concepts in more detail, there's a link to an additional reading at the end of this lesson.
In this video, you will further explore the concepts of components in React and learn how to create a component from scratch. You'll be introduced to the concept of the export statement and how components can be used to create reusable blocks of code. I've launched VS Code here and I have the creating component folder open in the built-in terminal. Now I'll execute the command npm init react app dot. The dot character instructs VS Code to run this command in the current folder. In other words, I'm using create react app to build a new app for me inside this folder. I execute this command by pressing the enter key. I wait for the app to build, and once it's ready, I can start the app by typing npm, then a space, followed by start. The process of building the React app could take a couple minutes, so just sit tight while it builds. Great, my React app has started and loaded in the browser at localhost 3000, which is the local server. Notice that I have all these files and folders in the left pane of VS Code now, such as node modules, public, src, and files like package.json. You'll learn more about these later. For now, the only folder I need to work in is the src folder, so don't worry about all these other files and folders. Instead, I want you to focus on how to build a component in React, and to do that, let's have a clean start. The easiest way to do this is to remove all the code inside the function inside the app.js file. I guess you might say this is the simplest possible component. I'm declaring an app function and I'm exporting it as a default module. I save my file and notice that my app is just a blank page. Now let me create another component that'll contain some text that I want to display in the browser. To do this, I create another function called header, and in the function body, I'll just return some greeting text inside an h1 JSX element. Inside the h1, I type hello world. My code looks good now, but my screen is still white. This is because I'm not yet rendering anything from my app function. To do this, I need to return to my app function and call the header function from it. I use the JSX element syntax to render a component, which is the name of my function. So inside the body of the app function, I create the return statement and type the function name of header inside left and right angle brackets, not forgetting to add the / before the right angle bracket. Notice that the syntax to render a component is very similar, to a self-closing tag in HTML. Press Ctrl S or Command S if you're on Mac to save everything again. Great, my code is working now, and I notice an HTML heading with the text "Hello World" displayed in the browser. Congratulations! In this video, you learned how to create a functional component. This component named app calls another component named header, which displays an HTML heading with some text. At the moment, the header component code exists in the same file as the app component. To make the header component isolated and reusable, I need to place it in its own file. Then I can reuse it multiple times in the application anytime I want to display a heading element with some text. And you'll learn how to do this very soon. In this video, you learn how to create a functional component in React and render it to the root component named app.js.
As you might already be aware, it's important to organize or structure your React components so that they're easy to access. But what does a structure look like? What files and folders are found within a typical React application? The React project structure is the focus of this video. By the time you reach the end of this video, you'll have learned how to explain the default folder structure of a React project, outline the benefits of the folder structure, customize the folder structure to hold components and assets, and explain the benefits of planning folder use for app development. Let's begin by examining how the default files and folders are laid out in a React app project. When you build a React app using the command npm init react app, your project is comprised of a specific file and folder structure. Notice that there are 3 folders named Node Modules, Public, and SRC or Source. Let's explore each of these folders briefly now. First, let's begin with the Node Modules folder. You can think of this folder as a repository for all the modules in your React app. The Node Modules folder is automatically added when you install a specific npm package. You might recall that packages are groupings of files and/or node.js modules. Developers use packages when they want to add a piece of functionality that someone else coded and made available to other developers via the npm ecosystem. Don't worry too much about the Node Modules folder. For now, just be aware of it and that it's needed for your React app to work. Next is the public folder, and it contains the assets that will be displayed to the user in your app. For example, image files for logos, the favicon which displays an icon in the browser tab, and the robots.txt file which is used for search engine optimization. Also, there is a manifest.json file which is used to provide some metadata to a device when your React-powered web app is installed on it. While all these files are necessary, the most important one to know about for now is index.html. A React app gets injected into the specific element inside the body of the index.html file. Based on changes happening inside a React app, it injects those updates in that same div of index.html. You'll find out more about how this works later on in the course. Finally, let's explore the contents of the SRC or source folder. This folder contains all the essential component files required to ensure that a React app functions. And notice that there are some files already in this folder. These were automatically created when I used the npm command create React app to build a starter React app. As a React developer, you'll probably spend most of your time within this folder, so let's get a little more familiar with some of these files now. You may be familiar with some of them already, such as index.js and app.js, which are used to render the root component of the app. Let's briefly explore the others. App.css contains the styles for the app.js component, and the index.css file contains the styles that are used in the entire app. App.test.js, setuptests.js, and the report web vitals.js are files related to the app's performance and testing. The logo.svg file is displayed on the start page of the default app when the app is displayed in the browser on the local host. While these can be useful and their functionality is important, I can still safely delete them without affecting React's abilities to create a very basic application. I just need to also remove the code that references them. This is because React doesn't have opinions on how you organize your files and folders in the source folder. However, there are a few common approaches popular in the ecosystem, and you'll learn about them soon. It's at this point it's also worth remembering that the most important file in the entire source folder is the index.js file. This file imports everything that this React app needs to render a working React app. Okay, so now you have explored the main folders. Let's explore the files in the root of the default app. Root files are additional files that are found in the root of the project folder itself and include a gitignore file, 2 JSON files, and a README file. The .gitignore file is used in version control, and it's used to specify what files and folders must be excluded from a project. It's important to know that this file is not specific to React. This means that other systems use this file too. The readme.md file is a markdown file that gives some basic information on this project. Developers use this when they want to share the project's code on a site like GitHub. The package.json file lists information pertaining to my app, which allows npm to run several scripts and perform various tasks in the app itself. Finally, the package.lock.json file holds the list of all dependencies with their specific versions. The package.json file helps npm rebuild the app on another machine, or if we delete the node modules folder with all the files that our project needs to run, the package.lock.json file has all the information for npm to be able to rebuild those files reliably. This file is there to ensure that npm tracks all the modules installations properly. As a general rule, it's better to leave these files where they are for the moment, as they are required for the app to function. You should now be able to explain the default folder structure of a React project and outline the benefits of the folder structure. In addition, you should know how to customize the folder structure to hold components and assets, and be able to explain the benefits of planning folder use for app development. Good job. One of the advantages of component-based architecture is that your app is split up into individual self-contained components. And as you have already learned, these components can be used to build powerful UIs based on reusable components of code. In order to create a fully functioning React app, you need to create a collection of components. But with the app broken into several different components, you might be wondering, how do you locate and integrate them all into your app? In this video, you'll learn about the concept of modules and how to manage your React components by placing them in a components folder. Finally, you'll explore the structure of the import and export statement. As a developer, you often need a way to use and reuse components that may have been defined elsewhere or created by someone else. For example, do you recall the concept of modules in JavaScript? Modules are standalone units of code that you can reuse again and again. Being standalone means that you can add them to your programs, remove them, and replace them with other modules, and everything will still work. Well, in React, you can make use of this JavaScript feature to separate your components by placing them in their own file. Then you can use the import and export statements to make the files communicate with each other. The export statement is used to make a module available to another module. It helps to think of every JavaScript file as a module. Then in order to make the functions and variables available to other files, you need to export them, which makes them available via the import statement. In JavaScript, there are two types of exports: default exports and named exports. The default export is used when the function name is the same as the file name, and named exports are used when you want the function name to be different from the file name. At this point, you may be wondering, what is the difference between modules and components, since they are both essentially just JavaScript files? And you're right. While they have similarities, it can help to think of a component as a single part or small piece of functionality, like a button. Then you can think of a module as something that's larger than just one component, like a series of components. This technique of splitting your code into several modules is known as modular programming, and it complements the component-based architecture of React. To help you understand this better, let's explore the following scenario. Suppose you're a developer currently in the process of building an application with React, and there are several components that need to be included in the app. Some of the required components have already been created by your fellow developers, so you need a way to import them into your app. To do this, you need to use the operation known as importing. And in React, you import components into your application using the import statement. You may have already noticed the import statement in the default index.js file where the app component is rendered. In React, to import a component, you use the keyword import followed by the component name you want to import. Then you use the keyword from to specify the location of where the component is located. You need to use a file name sequence such as a dot, / before the file name, but the file name extension is not required. Okay, so now you know about the syntax of the import and export statement. Let's explore how you can structure your component in React. Remember that a component is essentially just a JavaScript file. React doesn't have strict rules on how you put files into folders. However, there are a few common approaches you may want to consider. One approach is to place all components in a folder named components. This allows you to structure your projects by grouping similar files together. For example, suppose you are building a payment page for an e-commerce app. The page contains 3 sections that will each be represented by a component in React. First, a header section using a component called header, then a payment section using a component called main, and finally, a sidebar using a component called sidebar. Each component will be called and have its contents returned to the root component of our application, which is app.js. In this video, you explored the concept of modules and the structure of the import and export statement. You also learned how to manage your React components by placing them in a components folder. By now, you should be familiar with the concept of functional components in React. They are reusable blocks of code that act much like a JavaScript function. Recall that in JavaScript, you can make your functions more flexible by declaring them with parameters that allow you to pass in values as arguments when you call the function. Well, in React, you can perform a similar action using something called properties, which are represented as props. In this video, you'll learn about the props object and how developers use it to pass data from one component to another. Then, you'll explore component hierarchy and learn why components are said to have a parent-child structure. Before you begin your journey with props, let's revisit another piece of JavaScript functionality that will help you understand how props work. It's called the JavaScript object. Recall that in JavaScript, an object is a special type of variable that can contain many values. You use objects when you need to store groups of related data of different types, and each data type is known as an object property. For example, suppose you create an object called fruit that contains properties for type, quantity, and color. Remember that these properties consist of name-value pairs, and you can access the object's properties using dot notation. In React, you can use a similar technique to pass data from one component to another using the properties object, or simply props. Props allow you to pass data from one component to another. It's helpful to think of props as arguments that components can accept and are passed using JSX syntax, much like HTML attributes. Inside a function, you use the keyword props. Okay, now that you're familiar with the concept of props, let's explore an example to send some props to a component and print them out in a React app. Suppose you have the default code for the React app open. In the index.js file, you call the app component. Inside the app component, you return an h1 heading with some static title text. While this code works, you can make this heading dynamic by using props. Let's now explore the syntax involved to create this. In the root component index.js, you send the value you want to pass to the app component as an argument in the form of an HTML attribute. Next, in the app component, you accept this argument using the props object. To do this, you add the keyword props to the function declaration inside of the parentheses. Finally, to access this object's properties, you use dot notation to reference the name of the object property that was passed as an argument by the HTML attribute. Once again, remember to enclose your code inside curly brackets so React knows that you want to work with a props object and not static text. Because props is essentially a JavaScript object, it can accept many data types ranging from simple types such as strings and integers to more complex types such as functions, arrays, and objects. As a result, props allow developers to have greater flexibility when creating and working with components, especially when you want the flow of data in your app to be dynamic. While you just explored a basic example to dynamically print a heading, you'll get a chance to practice with more complex data structures using props later. Okay, so now you're familiar with how props work by sending data between components. Let's explore this data flow in a little more detail. When two components communicate with each other, the component sending the props data is known as the parent, and the component receiving the props data is known as the child. And as you've just learned with the example earlier, this parent-child relationship allows parent components to pass data down to child components using props. It's also possible for parent components to send the same data to multiple child components. However, it's important to know that this communication is a one-directional data flow. It's not possible to communicate from the child component back to the parent component using props. Instead, developers use other approaches. Don't worry about that for now. You'll learn more about them later. Although props are a very powerful tool in React, they do have some limitations. For example, you just learned about how it's not possible to send data from the child component back to the parent component using props. Another important limitation has to do with something called pure functions. In programming, a pure function is a function that will always return the same output for the same argument values that are passed in. Don't worry too much about pure functions for now. Just keep in mind that in React, when you declare a component using props, it must never modify its own props. In this video, you learned about how props are used to pass data to components. You discovered that a prop is a special React object that works in a similar way to a JavaScript object, and that its properties can be accessed by dot notation. You also learned why developers use props in order to make their apps more dynamic and flexible. Finally, you examined some of the limitations about using props in that you cannot use them to send data back to a parent component, and that functions using props must never modify its own props. By now, you should be familiar with the concept of props, and that they allow you to pass data from one component to another. Developers use props when they want the flow of data in the app to be dynamic. This makes the app more versatile, helping it consume data easier. In this video, you'll learn the syntax involved to use props in components. You'll also explore the passing of props to and within a component using functions. During this course, you were introduced to an example of how to build a simple blog layout in React using components. Now you'll be introduced to a new component called the nav component. Developers commonly build navigation menus using HTML unordered lists. A navigation menu is basically just a list which can be styled easily with CSS. Such a snippet of code is well suited to be placed in its own React component, making use of the HTML nav element to act as the block of code to return the JSX from inside the function. For example, the return statement can contain several HTML-like elements such as UL and LI tags. And this same nav component can also be rendered as a JSX element to which we can pass dynamic value with props. In order to do this successfully, you need to be comfortable with the concept of attributes. The best way to develop an understanding of attributes is with a live example of building a component using props. Here's a practical way to work with props. I'm in my app with the header, main, and sidebar components, and all of them are rendered from the app component. The app component is in this case referred to as the parent component, and the header, main, and sidebar components are referred to as the children of the app component. I'll now pass data from the app component to each of its children components. First, the header component receives a name prop with a value of Anna, and a color prop with a value of purple. I'm sending those props from the header JSX element inside the app component's return statement. press Ctrl S or Command S on a Mac to save these changes. However, my recompiled app is not showing any changes because I send this data through the props object to the header component. I'm not using this data in the header component. So let me open the header component and I'll first pass in the props object. For now, I'll just console log the props object. Again, press Ctrl S or Command S to save the update and wait for it to compile. If I now inspect this object in the console, I find the console logged props object and it comes with two properties, the name Anna and the color purple. I can now access the values of the two properties inside the header component using props.name and props.color. To make sure that the expressions are evaluated inside the JSX syntax, I must surround them with an opening and a closing curly brace. I press Ctrl S or Command S on the Mac again and wait for it to compile. Now my header shows the props data it received from the parent component. I'll now update the main and sidebar too. Back in the app component's render statement, I add the greet prop with the value of howdy in the main JSX element and the value of hi in the sidebar JSX element. I open the main component file and receive the props object, then output the value of opening curly brace, props.greet closing curly brace. I can now delete the hello string. Similarly, in the sidebar components file, I'll also receive the props object and replace the hello with an opening curly brace, props.greet closing curly brace. I click File, Save All, and wait for the app to compile. All my components are now using the data they received from their parent component, using their respective props objects. You should now be able to effectively demonstrate the passing of props to and within a component using classes and functions. Great work! At this point in the course, you've been introduced to the concept of JSX and how it's used to interact with components. In this video, you'll explore JSX in more detail in the context of component and styling. You'll also learn how to mix JavaScript, HTML, and CSS within a component. So, what is it that makes JSX so special? In one word, expressiveness. Developers can express what they want React to render using a very expressive syntax, almost identical to HTML or XML. In other words, JSX allows developers to write HTML directly inside JavaScript code. For example, you can add a navigation function to a website by creating a nav component, then place the HTML semantic nav element and an unordered list inside. And because this is React, the list values can be made dynamic by passing values as props. It's important to know that a regular JavaScript function is used to define how React should render the component, wherever it's referenced using the nav JSX element. And this is what makes JSX so powerful, like the fact that you can insert specific JSX expressions such as variables and props. The reason why this is so great to work with is because anything that's placed inside the curly braces of your code is essentially regular JavaScript code. For example, you could calculate a series of simple expressions using the li or list item tag. This means that you can think of the curly braces as being special areas where you can write any kind of JavaScript code you like. And you can write the rest of the code inside the return statement. Okay, so now that you've learned a little more about JSX expressions, let's focus on some JSX rules inside the return statement of the function. The return statement can be thought of as the area of expressive syntax that allows you to write regular HTML code as you'd like to have it in your rendered app. But if you need to return HTML code over multiple lines, it must be placed inside parentheses. This allows developers to alternate between regular HTML tags and dynamic values represented as JSX expressions inside curly braces. It's also important to remember that the HTML code must be wrapped in a top-level element, such as a div tag. If you do not want to add extra div elements to the DOM, you can use something called a fragment instead. This is like an HTML open and close tag without the tag name. While you can think of the code inside the return statement as regular HTML, it's worth remembering you are in a JavaScript file, and as a result, there are some differences. For example, you cannot use the keyword class to work with CSS classes in your HTML elements. This is because class is a reserved keyword in JavaScript. You must use a slightly different keyword called class name instead. Also notice that class name is written in camel case, which depicts the separation of words by using a single capitalized letter. You can use class name to list any number of CSS classes to style a specific JSX element inside a component. This is just like how you use the class attributes in regular HTML, and it's only one of the many ways you can style React apps. You'll learn more about how to do this later. For now, just know that this is the closest to what you would do, like if you were working with HTML and CSS website layouts. There are some other differences, and you'll learn about them later. But in practical terms, you can consider the code to be pretty much just like regular HTML. In this lesson, you explored further the concept of JSX styling and how it's used in React. You have now furthered your understanding of how to use JSX to mix JavaScript, HTML, and CSS within a component. Great work!
Recall that there are 3 techniques to include CSS in HTML documents. The first is inline by utilizing the style attribute inside the HTML element. Next is internal by using the style element in the head section. And finally, external by linking to an external CSS file using the link element. In this video, you'll learn how to take CSS style rules from an external file named index.css and add it inside a component as an internal style. These style rules can then be referenced by your code inside the return statement of the component. Notice that the components are styled by the external style sheet index.css. For this video, I'll continue working on an app which consists of the components header, main, and sidebar. This time, the focus will be on using internal styling inside the sidebar component. To demonstrate this, I don't need to move all the code from the index.css file. Instead, I'll just focus on the styles related to the sidebar component. For example, I select the CSS code for aside and cut it by pressing Ctrl X or Command X on Mac. After saving, notice that this removes the styling from the sidebar component displayed in the browser. Now let's go to the sidebar.js file where I'll paste the code before the return statement. This will not affect my component because I'm pasting CSS code into a JavaScript file, so I need to make some changes to turn the CSS rule into a JavaScript object. To do this, I need to declare aside style as a cons variable and then replace the semicolons in the code with commas. I also need to replace the hyphenated names with camel case. It's important to know that because CSS declarations like background are now an object property, I need to make their respective values a string by wrapping them inside double quotes. And I also need to repeat this for the other new style elements as well. Finally, inside the aside tag in the return statement of the component, I need to add a style attribute by typing style equals aside style as a JSX expression. I then choose Save All in the File menu to save my changes. Notice that the sidebar component appears in the browser as before I edited the index.css file. So that's an example of using inline CSS styling directly inside a component. In this video, you learned how to take CSS style rules from an external file named index.css and add it inside a component as an internal style.
Recall that JSX is a syntax extension to JavaScript that is used with React. It allows developers to write HTML as part of their component code, and is frequently used in React as it offers greater flexibility. In this video, you'll learn how JSX is used and how to use its key feature, embedded expressions. First, let's examine a JSX example that will output some text on a web page. The code consists of a paragraph HTML element containing the phrase "Hello World." It is assigned to the constant variable named result. Note that when this JSX code executes, the result variable will contain a React element that can then be inserted into the web page. This is one of the key features of JSX, building React elements from HTML code automatically. Let's explore another important feature of JSX, which is embedded expressions. Embedded expressions allow developers to insert the values of JavaScript variables into the HTML of the resulting React element. Embedded expressions can also embed the output of functions. Let's say you need to output the person's name in a specific format. To do this, you can first create a function named formatName that will return the first name and surname with a space character between them. In your JSX, you can then call this function inside the curly brackets. As with the previous example, the value that the function generates for the JavaScript variable will be output in HTML. Expressions can also be used for HTML attributes. This is useful if you need to insert the address of a person's profile picture. To do this, first you would store the profile picture address in a variable named URL. The image will be displayed using the img element, so you should embed the URL variable into the src attribute. Note that the double quotes are not needed for the attribute value, as JSX will automatically add these. This is just one example of how JSX is an efficient way of outputting HTML elements that contain JavaScript variable content, and you'll encounter more as you progress. In this video, you explored several JSX examples, including one that uses embedded expressions to insert the values of JavaScript variables into HTML within a React element.
I'm building an application using React, and I now need to add a new feature to the app that renders images. I can do this by embedding a JS expression in an attribute, specifically the src attribute of the HTML image tag. Over the next few minutes, I'll guide you through the process as I complete the steps, and by the end of this video, you'll be able to demonstrate how to embed a JS expression in an attribute, including adding additional styling and importing additional assets, and utilize additional assets within an app by importing components. Now I'm in the app.js file of a new project and start with an app component that returns the h1 header text Hello World. I've previously copied the avatar profile image from the Coursera GitHub account, which is publicly available through the GitHub API. I've pasted the images into the root of the src folder and named it avatar.png. In order to use the image, I need to import it into the app component. I then add a new function in the app.js file named logo. The logo function is essentially a separate component, but to keep things clean for this example, I'll save the code in the app component instead of a separate file. The logo function accepts the props object, and inside of the logo function, I declare a user pic const and assign it a JSX element. This is an image element, and I'm passing the imported avatar PNG image as the value of the src attribute inside this image element. Finally, I'm returning the user pic const from the logo function. Back inside the app component, I'll now render the logo component by adding the logo element inside the app component's return statement. Let me now preview my app in the browser. Great, so it displays the header text along with the image. Keep in mind that if I were to continue building this app with more components, it would be best to extract the logo component to its own file and then import and render it as needed. And that's a demonstration on how you can embed a JSX expression in an attribute, in this case the src attribute of an HTML image tag.
Well done! You've reached the end of this module on React components. Module 1 gave you an overview of the basic structure and use of React.js. The purpose was to enable you to produce single-page applications with React. Let's take a tour of the lessons to determine how it did just that. First, you learned about how React is used in the real world from Meta software engineer Katie. Then, to lay the foundation for the hand-on labs, you had a quick summary of the fundamentals of HTML, CSS, and JavaScript. And then you learned how to set up a project in VS Code and how to work with JavaScript modules. The second lesson was all about React components and where they're stored within your applications. In this lesson, you were introduced to component-based architecture, a design philosophy for building software based on reusable components of code. like the React library. You learned about component types and component style layouts that use the virtual DOM. And you learned how to create components that form the foundation of UI design. In this lesson, you also learned more about JSX, a special kind of syntax that acts like an extension of JavaScript. You learned how to transpile it, in other words, convert JSX to HTML, which helped you to understand how a component is built. And in the ungraded labs, you learned how to build a new component inside the app component and have it rendered on screen, as well as how to save a component to its own file and importing it into its parent component so that it can be rendered on screen. The third lesson was about component use and styling. You learned how to pass data from one component to another using properties, and your ability to do so was tested in the ungraded lab. And in the other ungraded lab, you learned how to render one component multiple times using different props. You also learned more about how to use JSX and its embedded expressions, and how to style JSX elements in a way that is functional and looks good. As part of this lesson, you learned how to use and manipulate props and components, define components using function expressions and arrow functions, invoke functions inside of JSX expressions, use expressions as props, declare components that require props, and use expressions and embedded expressions in attributes. After completing this module, you are now able to explain the concepts behind React and component architecture, create a component to serve a specific purpose, create a component folder and demonstrate how to create and import files within that folder, use and manipulate props and components to affect visual results, and describe how to use assets within an app to apply styling and functional components. That's a great start to your React journey. Well done on completing this module, and get ready for the next one.